Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, how are you today? Hope you believe are always in good condition. Who I respect, Mr. Professor Dr. Sutarto Hadi MSc MSc, Miss Kamalia MPD, and Miss Rahmita Norbaiti MPD as a lecturer in Mathematics English courses. Let me introduce myself. My name is Tiara Paramita. My ID number is 211-011-81200008 from Group 9 in Mathematics English courses. Today, I will explain about the last second meeting about probability. In probability, we have 3 points, is vocabulary, video, and example. Okay, we can go to the first material is vocabulary. Vocabulary 1 is apothegm. Apothegm is a line drawn from the center of any polygon to the midpoint of one of the sides. The example is um, example from apothegm is picture here. In here is apothegm. Next is arc. In mathematics, an arc means a part of curve or the portion of a circle. The straight line joining the ends of the arc is called the chord of the circle. Example is, from picture here, we have information the arc of a circle is defined as the part of segment of the circumference of a circle. A straight line that could be drawn by connecting the two ends of the arc is known as a chord of a circle. If the length of an arc is exactly half of the circle, it is known as a semicircular arc. Next is sector. A sector is a portion of a circle that can be defined based on the 4 points mentioned below. The example is from picture here we have sector. This is a sector. In green is sector. So a portion of the circle is covered by two radii and on Earth. A circle is divided into two sectors, and the divided parts are known as minor sector and major sector. Next is radius. In geometry, the radius is defined as a line segment joining the center of the circle or a sphere to its Next is radius. In geometry, the radius is defined as a line segment joining the center of the circle or a sphere to its circumference or boundary. The example is from circle here, from here to here, this is a radius, and from here to here is diameter, and here to here is center. So this is a radius. Is the right. Okay, next is compass. A compass is used in mathematics for drawing and drafting to create arcs, circles, or other geometric figures that can be determined by measuring interesting line segments. Next is chord. The chord of a circle can be defined as the line segment joining any two points and the circumference of the circle. It should be noted that the diameter is the longest chord of a circle which passes through the center of the circle. The figure below depicts a circle and its chord. The example is from circle here, we have line here. From here to here is R or radius, and here to here is chord. Here is here chord. Here to here is diameter. Okay, next is center. The term center or center is used in various contexts in abstract algebra to denote the set of all those elements that commute with all other elements. The example is from picture here. We have a center is here. Yeah. Next is radii. In geometry, the radius is defined as a line segment joining the center of the circle or a sphere to its circumference or boundary. It is an important part of circles and spheres, which is generally abbreviated as R. The plural of radius is radii, which is used when we talk about more than one radius at the time. The example is this is here to here is radii. Next is central angle. A central angle is an angle with endpoint and located on a circle, circumference, and vertex located at the circle center. The example for central angle is yellow is angle AOB is central angle. Next, the last vocabulary is inscribed angle. In geometry, an inscribed angle is the angle formed in the interior of a circle when two chords intersect on the circle. It can also be defined as the angle subtended at a point on the circle by two given points on the circle. Equivalently, an inscribed angle is defined by two parts of the circle sharing an endpoint. The example for inscribed angle is pictured here. In the above image, AB, the intercept arc theta, equals to the inscribed angle, and 2 theta, the equals to the central angle. Theta equals to the inscribed angle. ACB is inscribed angle, and 2 theta is the central angle. AOB as the central angle. Okay, the next material we can explain about video about probability and combinatorics is handscape. Handscape combination. There are 4 people in a room, A, B, C, and D. They all meet each other and must have hands exactly once from every person in the room. So if each of these people, each person needs to sex everyone, also and hatch exactly once how many handshakes will occur. The solution is, let's assume that people always going to sex someone else's hand. So we can A, B, C, and D. A, B, C, and D. And the box one is 4. A, B, C, or D. In box one, we also 1. So, we box 2, 4 minus 1. equals to 3. So 4 times 3 equals to 12. So there are 12 possible handshakes. But what happens if the order in this handshake is not noticed? So A, B, C, and D, not this is position, is the same thing. If the order in the handshake is not noticed, so it's going to be combination. From 4 people in a room, who may wise to choose 2 people for doing a handshake? Combination 4 of 2 equals to 4 factorial divided by 4 minus 2 factorial times 2 factorial. So, equals to 4 times 3 times 2 factorial divided by 2 factorial times 2 factorial. 2 factorial divided by 2 factorial equals to 1. So, 4 times 3 divided by 2 factorial is 2. So, 4 times 3 equals to 12 divided by 2 equals to 6. So, that 6 wise to choose 2 people for doing a handshake from 4 people in a row. Okay, next is example. Next material is example. Okay, the first material example is example 11. The question is, a bag of candy contains candies of different fruit flavors. 4 candies are strawberry, 8 are lemon, and 3 are cherry flavored. If the candies are picked at random without replacement, what is the probability that they both will have the same flavor? So from the question, the solution is, from question we know that experiment is picking 2 candies, and outcome the 2 flavors are picked, and a successful outcome is the flavors are the same. In strawberry candies is 4, lemon candies is 8, and cherry candies is 3. So the total candies in the bag is 4 plus 8 plus 3 equals to 15 candies. The question is the probability that they both will have the same flavor. So the total number of outcome we can substitution in the permutation formula. So permutation 15 of 2 equals to 15 factorial divided by 15 minus 2 factorial. So 15 minus 2 equals to 13. So 15 times 14 times 13 factorial divided by 13 factorial. 13 factorial divided by 13 factorial is 1. So we have 15 times 14 equals to 210. So there are 210 different ways to pick 2 of the candies. So next, to find the number of successful outcomes, we have to addition the number of ways to pick 2 candies of each flavor. There are 4 times 3 equals to 12. So 12 ways to pick strawberry candies is permutation 4 of 2. 8 times 7 equals to 56 ways to pick lemon candies is permutation 8 of 2. And 3 times 2 equals to 6 ways to pick cherry candies is permutation 3 of 2. The number of successful outcome equals to 12 plus 56 plus 6 equals to 74. The probability of picking two candies of the same flavor is probability of an event equals to number of successful outcome divided by total numbers of outcomes. So 70, 74 over 210 equals to, we can divide it by 2. So 74 divided by 2 equals to 37, and 210 divided by 2 equals to 105. So we can percent. So is 35%. Uh, Why 35%? So 37 divided by 105 equals to 0.352. So we can, the percent is 35%. So the probability that they both will have the same flavor to the nearest thousand is 0.352, or to the nearest percent is 35%. Okay, the second example is example 12. The question is, a card is drawn from an ordinary deck of 52 playing cards and replaced in the deck. A second card is drawn. What is the probability that both are fixture cards? So the solution is, from the question we know that the experiment is picking two cards. And an outcome, the types of card picked. And a successful outcome is the two card or victor cards, jacks, queens of the kings, not necessarily the same. And the total card is the deck is 52 cards. So there are 12 picture cards in the deck. So the question is the probability that both are picture cards. The picking to card is done with autofon again equals to 52 times 52 equals to 2,704. Therefore, there are 2,704 different outcomes. The sample point of picking two picture cards is 12 times 12 equals to 144. So the number of successful outcome is 144. Okay, so the probability is probability of an event equals to number of successful outcome over total number of outcome. So 144 over 2,704. We simplifying, we have 9 divided by 169. So the probability that picking both of picture card is 9 divided by 169. Next is example 13. The question is, a 5 coin is tossed 5 times. What is the probability of getting 5 hits? So the solution is, from the question, we know that the number of successful outcomes from a coin is 1, and the total number of outcomes from a coin is 2. The question is the probability of getting 5 hits. So the probability of getting a head on one toss, number of successful outcome over total number of outcome equals 2. 1 over 2, 1 half. Solving the problem with counting principle. So half times half times half times half times half equals to half, the power of 5 equals to 1 the power of 5 over 2 the power of 5. 1 the power of 5 equals to 1. 2 the power of 5 equals to 32. So the probability of getting 5 heads is 1 over 32. Okay, the last example is example 14. The question is, the monthly rainfall for Manchester, US city for the past year is given in the table below. How many months would you expect rainfall between 2 and 3 in over a 5-year period? And from question we have that is this is a month from January uh, to December, and this is inches the inches in the month. So from the question in the table, we know that three there is 3 months. It's January, February, and December. What do you expect rainfall between 2 and 3? And in 5 years, consisting of 60 months. And the number of successful outcome in year is 3, and the total number of outcome in a year is 12. The question example 14 is, how many months would you expect rainfall between 2 and 3 in over a 5-year period? So the probability of between 2 and 3 in of rain in 1 year equals to number of successful outcome over total number of outcome equals to 3 over 12. We can simplifying equals to 1 over 4. Over a 5 years period, which is 60 months, the month will expect rainfall between 2 and 3 in over 5 years period. The probability in 1 year times 60 months equals to 1 over 4 times 60 equals to 15. So expect that over a 5-year period, which is 60 months, there will be 25% of 60 or 15 months in which the rainfall is between 2 and 3 in. Okay, that's my presentation. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.